So good morning students, today I am going to explain about the dynamic memory allocation. So this video basically covers the static memory allocation, means what is the drawback of array, and then dynamic memory allocation and how this dynamic memory allocation can be achieved. So normally we can use two library functions. First is malloc and second is calloc, and we will also see an example in which we will use this dynamic memory allocation function, that is malloc. So let us see. So first of all, let us consider an array of 100 elements. Say int age is 100. So it means it will reserve 200 bytes in memory. So we are familiar with the array and how we can declare it. Now if suppose we are using only 50 elements, 50 locations, so storing only 50 values, results wastage of memory. So we are using only 50 locations, it means we are wasting other 50 locations. So this is the drawback of array. This is drawback of array. Now moreover, if suppose we wish to use more than 100 locations, then also it is not possible due to the limit, and this is the limit of size of array. So it is not possible to store the values more than 100. So this is short in size, because array is short in size, because the limit of array is 100 elements. So it is also not possible. Now we can say we cannot increase or decrease the size of the array at runtime. So we cannot increase or decrease the size of array at runtime, and this is known as static memory allocation. Because we have declared the size of the array in advance, so this is static memory allocation. Now if you wish to allocate the memory at runtime, and how it is possible? So it is possible using two library functions, that is malloc and calloc. So further we can say, if we wish to allocate memory during the execution of program, then it can be done using two library functions, that is malloc and calloc, and this is known as dynamic memory allocation. This is known as dynamic memory allocation, and these two functions are known as dynamic memory allocation functions, and the two functions it is are known as dynamic allocation functions. So they are known as malloc and calloc. They are known as dynamic memory allocation function. Now we will see its example. Means how we can use this malloc function. So this is the program to find the average of n numbers using malloc. So here we will use malloc function. Now, so we can start from the header files, include stdio.h. So this is a program in C, and then include conio.h. As we know that getch clear screen are defined in this header file. So we are familiar with these header files. These are very basic files, and then we will use another important header file, stdlib.h. It is standard library header file, and it includes like exit function. Now void main. Now we will declare the required variables, because we will enter n numbers, so we will require a variable n. Then we will require a variable I, because we want to find out the average, so we will also need a variable average, and the most important variable, that is pointer variable, we will use, to which we have to allocate the memory dynamically. So int n I average and then sum equals to 0. These are the 4 variables that we will use in this finding the average for n numbers, and then one pointer variable. So these are the variables that we will use. Now printf enter the value of n. So this is the simple function that we know. We can enter the value of n from the keyboard, so we can use these two functions, printf and scanf. Now the next step, which is very important, we will allocate the memory to this P. This P so here we will use the Malloc function. So this is the main important point of this program, or we can say this dynamic memory allocation. This is the part we can say where we are using the memory dynamically, or we are allocating the memory during the runtime. So here this is the pointer variable. Here we are doing this typecasting. So this typecasting is necessary because typecasting, because this Malloc returns pointer to void, and here we are using the n numbers, because we are using n numbers, and because this is of integer types, that's why we are multiplying with 2. So in this way we are allocating the memory dynamically, and this typecasting is also necessary to convert in the integer. After that, if suppose this memory has not been allocated, then what will happen? So we can use the code if p is equals to null, then print a memory allocation unsuccessful, and then exit 0. It is to be noted here we are using this parameter 0 because if suppose we are not entering this 0 here, then compiler will ask to enter the parameter. So we can say we are using this 0 here, otherwise it will show the error. Moreover, this exit is defined in the standard header file. Now we will use a loop, for loop for I equals to 0, I less than n, I plus plus, and then scanf. We will store all the values at these locations. So we will use here p plus I. So all the values at different locations that we are using for those we have allocated the memory. So in this way we can enter the value from the keyboard, or these values are stored. So after getting the value from the keyboard, what we will do, we will again use a for loop for I equals to 0, I less than n, I plus plus, and then sum equals to sum p plus I. This is also very important point here. Here we are using the value at address operator. So in this way we can use all the values. So here we are using this sum equals to sum plus. This is the logic. Here we are using the logic address operator. We can retrieve here, and then ultimately we can find the sum. After getting the sum, we can find the average. So this average is sum is divided by n. So it will give the sum, and after getting the average, we will print it, printf average equals to avg. So in this way we can print the average of n numbers. So this is the full program by which we can find out the average. So we can also see its output. It is also very simple. Output. So first of all, it will ask to enter the value of n. So suppose we enter the value, say this is 3, so we can put a colon here. So this is say 3, and the values are 10, 10, and then 10. So average, this will be 10. So this is the output. So in this program, the important point is this is the important point. This is important point 1, and then this is also important because at this point we are checking whether the memory has been allocated or not, and here we are, with the help of this, we are entering the value from the keyboard, and then sum here. So at these addresses we are retrieving the values with the help of which we are finding the sum, and then ultimately we are finding this average. So in this way we can find out the average. So I hope that you would be benefited in this video, from this video. In this video we have seen what is static memory allocation and what is dynamic memory allocation, and how we can achieve this dynamic memory allocation using the Malloc function. Thank you.